Hello everyone. Good afternoon. Pa-thumbs up kung narinig niyo ako. Okay, great. Thank you. So, uh, yes. So, nag-message ang isa sa mga kaklase ninyo na appropriate yata yung kanta. Wala raw sagot sa mga tanong. Tama ba? Okay, let's begin with a quick review kung ano yung ginawa natin last time. Okay. So last time, ang diniscuss natin ay itong multivariate linear regression. Okay. So dito sa multivariate linear regression, um, tawag dito, uh, ginamit natin yung linear regression as a means to classify uh, features. Okay? Ang example na ginamit natin dito ay yung features ng isang kotse at tinignan natin yung um, mileage. Okay? Or hindi mileage, kundi fuel consumption ng kotse based on yung features na acceleration, number of cylinders, displacement, horsepower, at saka weight. Okay, so ang ginawa natin dito is yung mga input variables natin o yung mga features natin, itong mga to nabanggit ko. Ito yung mga input variables at yung output variable is yung miles per gallon. So the basic idea is uh, input mo yung parameters mo, okay, tapos tawag dito, i-compare niya yung parameters na yan with the miles per gallon. Tapos yung machine yung maghahanap nung pattern. Kung alin sa mga parameters na to yung nagbibigay ng pinakamalaking effect dun sa miles per gallon at alin din sa mga parameters na to yung pinakamaliit yung effect. So yun yung isa nating ginawa last time. Then nakita natin na yung linear regression ay hindi naman ganun tawag dito, medyo limited yung kanyang um, applications, basically because linear lang kasi yung linear functions lang yung pwede niyang pag-aralan. So in the case na tawag dito, in the case of classification, hindi na mag-work ang linear regression, and instead pinag-aralan natin yung better na type, uh, which is called logistic regression. Tinawag natin ang logistic regression sort of makes a classification, a binary classification, like yung example natin last time, between, uh, for example, a tumor size, at yung tumor size, at depende sa tumor size, malalaman natin kung ano kung tawag dito, benign siya or hindi. Okay, then we also talked about what's called a decision boundary. Okay, so pinag-aralan natin yung decision boundary kasi yung decision boundary na yun will tell us kung ano yung tawag dito, kung ano yung papasok within the boundary or lalabas within the boundary. So in that sense, naka-classify natin siya. Like in this example, meron tayong grades ng students. So dalawang grades to, okay, ng maraming students. So grade nila sa first exam, grade nila sa second exam. And base dun sa grades na yon, napipredict nung model kung yung student ay papasa or hindi dun sa exam. At yung model na yon will tell you kung papasa siya o hindi base dito sa decision boundary. So kung nasa baba siya ng decision boundary, babagsak yung student, at kung nasa taas siya ng decision boundary, nasa taas papasa yung student. Okay, and sinend ko sa inyo itong mga codes na to last time. Okay, I don't know kung pinag-aralan nyo na, pero I hope na nabigyan nyo to ng oras para tignan. Okay, or at least bibigyan nyo ng oras para tignan. Okay, now what we're going to do is we're going to discuss neural networks. Okay, so sa neural networks, okay, dito na lang ako mag-stick sa slides. Hindi ko na ipatawag dito sa slide presentation. Hindi ko na ipa-presentation format. Okay, so sa neural networks, okay, or first of all, bakit natin kailangan yung neural networks? Okay, so ito yung basic idea. Okay. Meron kayong ganitong image ng isang flower, for example. Ang naisip nyo gawin is mag-classify ng iba't ibang flowers, okay, gamit ang machine learning. Okay, so of course, for us humans, madali lang gawin yan, di ba? Kasi when you look at a flower, ang tinitingnan natin ay yung certain features niya, like for example, yung petal size, color ng petals, tapos yung ano bang tawag nila dito sa gitna. Okay? Ah, yan, kung ano man yung meron dito. Minsan tinitignan din natin yung number of petals, yung arrangement, and so on and so forth. Okay, so and we can do that like instantly as humans. Okay, now for computers, it's a little bit hard for them to distinguish these things. In fact, wala pang sort of conscious effort, wala pang program or wala pang AI model na makakagawa ng conscious effort the way humans classify yung ganitong klaseng mga objects. Ang approach ng computers dito is basically through certain features, and one of those features ay yung color intensity. So itong flower na to, itong image na to can be described by its color. So we can in MATLAB we can write yung color niya, okay, in terms of yung tawag dito, in terms of these numbers. At itong numbers na ito ay yung RGB values. So red, green, blue values niya, di ba? Yun. So pag 0 ay white at 1 ay sorry. Yung numbers na ito range from 0 to 256. So ito nasa 34, di ba? And then ito naman nasa 32. Tapos, ang ibig sabihin nun is bawat pixel dito sa image can range from 0 to 256. And pag 0 siya, if I remember correctly, it's white. At pag 256 siya, it's black. Okay? Uh, okay. Um, so ganun yung idea. So, somewhere in between ay yung mga colors. Okay? Titignan natin yan mamaya sa code. Okay, so that's how or that's the information na feed natin dun sa computer. Okay? So if an image has 1680 tawag dito, pixels vertically, tas 2240 pixels horizontally, okay, di meron na siyang 3,763 pixels. Now, itong image na to also has 3 layers. Okay? Kasi one layer for the red, one layer for green, and one layer for blue. Okay? So, multiply nyo pa to by 3, that's how many pixels, or that's the amount of information that's contained in just this simple image. Okay? In the same way, dito naman, obviously ito ay hindi flower, but for a computer, hindi niya nakikita yung mga yan. Ang nakikita niya lang are just numbers. So, ang nakikita ng computer is meron ditong 1,166,400 pixels per layer at meron siyang 3 layers, red, green, at saka blue. Yan yung feed natin sa computer. Yan yung input parameters at yan yung features, okay, na natututunan or napag-aaralan ng computer. Okay, so from dun sa previous example, ano, so from yung kanina na example natin about cars, meron tayong 6 lang na features. Two, dito, sa image ng flower, meron tayong millions of features. Diba? So imagine niyo kung gagamitin niyo yung linear regression or logistic regression on these types of on this type of image with this amount of information. May imagine niyo kung gaano katagal yung yung learning process ng computer. So there has to be some sort of way para lang ma-improve yung tawag dito, yung computation or yung learning ng computer. And the way to do that is through what's called neural networks. Okay, so ito yung ito yung idea, 'di ba? Sa isang sa isang image, ito yung pixels niya sa isang layer. So let's say this is for the red layer, ito yung R number niya, RGB number niya, okay, for this pixel. Then for the next pixel, ito yung RGB number niya. So ang ginagawa natin o ang ginagawa dito is this. So kung gusto mong turuan yung computer na mag-classify between flowers. So halimbawa tatlong flowers. Hindi mo lang siya bibigyan ng tatlong images. Okay, bibigyan mo siya ng maraming images nung tatlong flowers na yon. So halimbawa, well, may example tayo dyan mamaya. So meron tayong tatlong flowers. The more data na ibigay mo sa computer, okay, mas magiging accurate yung pag-classify niya dun sa mga flowers na 'yan. Okay, so how do we feed that sa computer? So itong pixels na ito, itong number of pixels na 'yan, ang gagawin natin diyan is so ngayon nakaano siya, 'di ba? 1680 by 2240. So parang ano siya, naka-rectangle, 'di ba? So naka-array siya. So ang gagawin natin diyan, i-convert natin ito into a 1 by 3.7 million, okay, array. Okay? So it's a single row array. Okay? Madali lang yung gawin sa MATLAB at sa Python. So ngayon, ito yung isang picture mo ng isang layer. Okay? So itong picture na ito, itong row na ito corresponds just to one image. Itong row naman na ito corresponds to another image. And then so on and so forth. So bawat isa sa mga rows na to corresponds to one image. Okay, so one row, one image per row. Now, maglalagay tayo ng additional column dito sa dulo. Bakit? Kasi i-label natin yung picture na yon. Now, the computer only understands numbers. So, hindi mo pwedeng sabihin sa computer na, okay, itong picture na ito ay itong flower na ito. Okay, let's say iris. Okay, hindi ganon. So, what you do is you tell the computer, is you write down numbers. For example, i-assign mo yung iris as 1, and then i-assign mo yung not iris as 0. So, itong image na ito, if this is iris, lalagyan mo dito 1, dito sa extra na column na ito, sa last column. Dito naman, second image, dahil hindi siya iris, lalagay mo 0. Itong third image, dahil hindi siya iris, lalagay mo 0. Itong last image, dahil iris siya, lalagay mo 1. So that's how we label each of these pictures. Okay? So again, isipin nyo kung gaano kalaki ito. So this is 1 row by 3.7 million. Magdadagdag ka pa ng isa pang column para dun sa labels. Okay? So, imagine niyo kung gaano kalaki itong array na ito. Tapos kung meron kang 1,000 images, so this is 1,000 by 3.7 million na array. Okay? So this is an extremely large data set na i-feed mo sa computer, and that's tawag dito, it's computationally expensive in the sense na it will take a lot of memory for the computer to go through this information, and it will also take time para i-process ng computer itong information. Okay, so kaya natin kailangan yung yung neural networks. Neural networks makes it a lot easier or more efficient para i-process itong information na ito. Okay, so again, yung idea is nothing new. Imagine niyo before, ito yung mga features sa kotse, ito yung mga features ng kotse. And then yung last column ay yung miles per gallon. Okay? Dito, ang nagbago lang is dumami lang yung features, pero yung last column ay yung label, okay, yung bawat picture na yun. Okay? So, walang pinag-iba in terms of yung tawag dito, um, description nung array. Okay, walang pinag-iba siya dun sa logistic regression na ginawa natin before. Okay, so this is a biological neuron. Okay, ang neuron of course is a brain cell, di ba? So a single brain cell basically looks like this, di ba? So meron kang cell body and then meron tayong itong mga dendrites. Okay, so extensions lang to from the cell body. And then there's this long extension which is called the axon. Okay, okay, so which is called the axon. Tapos, basically, itong mga dendrites, ito yung mga inputs dito sa neurons. Tapos, ito yung nagko-process ng information. Okay, and then, once na ma-process niya yung information, ibabato niya yung information na yan dun sa axon. At yung mga axons na yan ay nakakonect din sa ibang mga neurons. So, these axons will act as inputs to or they are connected to the dendrites of the other neurons. Okay, so ganun yung nangyayari. Okay, so in the same way, we have what's called, well, yung mga data scientists, they like to call this a perceptron. Okay, pero this is just a perceptron is just the analog of a neuron, okay, sa humans, sa human brain. Okay, pero it acts basically the same. Okay, so meron tayo nitong input, okay? At bawat isa sa mga input na yan ay merong weights, W1, W2, W3. Ngayon, yung weights na yan, okay, will be processed through this activation function. And then yung activation function, okay, maglalabas siya ng output. Okay. Now, we have all these new terms, okay? Pero, napag-aralan na natin actually itong mga ano na to, itong mga terms na ito. Yung input na x1, x2, x3 is the same as yung pinag-aralan natin before na x1, x2, x3 dun sa linear tsaka logistic regression. Itong mga weights na ito is exactly the same as yung mga theta values. Theta 1, theta 2, theta 3, and then may theta naught ka pa for the bias. Itong activation function, okay, ang ginamit natin na activation function before ay yung logistic regression. Kung naalala nyo, G, yung pangalan ng function na yun, so G of Z, okay, ang G of Z is equal to 1 over 1 plus exponential minus Z. Okay, so yun yung logistic regression function. At ang ginawa natin sa logistic regression function ay pinasok natin siya dun sa summation, okay, at naglabas siya ng isang tawag dito, ng loss function. Okay, so this is basically G. Okay, at yung G na yan ay magbibigay ng output. Okay, so again, although may mga bago tayong terms dito, this process is precisely the same as the process that we've already studied earlier. Okay, so that's one neuron, and this one neuron is just a piece of a bunch of neurons which we call a neural network. Now, each neural network ay may tinatawag na node. Okay, so let's just go. Saan na ba yung picture no? Okay, so for example ito. Okay, so this is one example of a neural network. Okay. So ito ay neural network at bawat isa sa mga neural networks na ito ay tinatawag natin na nodes. Okay, so there are 7 nodes here. Okay, and each neural network ay merong number of layers. Yung very first layer ay tinatawag na input layer. Yung very last layer ay tinatawag na output layer. So yan yung hypothesis natin. Okay, at yung any layer in between the input at saka output ay tinatawag na hidden layers. There can be more than one hidden layers. There can be many hidden layers. Depende sa features na anong tawag dito na napag-aaralan mo. Okay? Okay, so balikan natin yan mamaya ng konti. Okay, now ang gusto kong pag-focusan natin ngayon is this activation function. Now, nabanggit ko na yung activation function before ay yung logistic regression or sigmoid logistic. Ito. So dito sa slide na to makikita nyo itong sigmoid logistic. Okay? Before, we also used itong linear function. Okay? So itong dalawa, napag-aralan na natin. Now, ano bang ginagawa ng activation function? So the activation function basically decides whether a neuron should be activated or not. Okay, so sa sigmoid function, di ba? If you activate it, then ibabato mong output is 1. If you do not activate it, then ibabato mong output is 0. Okay, so yun yung ginagawa ng logistic, tawag dito, logistic function. Okay, now there are other activation functions which are actually much better. Especially pagdating sa image classification. Okay? So, of course, ito pinag-aralan na natin before. Okay? Sigmoid function. Ang advantage nito is these are useful for models where the prediction is a probability in the range between 0 and 1. Okay? Another advantage is differentiable at saka continuous yung gradient niya, which is good kasi 'di ba para ma-implement natin yung gradient descent, kailangan natin yung derivative niya, and gusto natin na yung derivative ay ang tawag dito ay continuous. Okay. Ang disadvantage nito is that it suffers from what's called a vanishing gradient problem. Okay, di-describe natin yan later. Now, another type of activation function is the hyperbolic tangent. Okay, it looks like this. Makikita nyo na pareho lang siya sa sigmoid. Okay, pero sa sigmoid kasi, tignan nyo yung range. So yung 0 ng sigmoid corresponds to 0.5 na output. And then anything below 0, okay, is 0 na output. And anything above 0 is 1 yung output niya. Okay. Now, sa tangent, okay, yung middle point niya dito is already at 0, 0. Okay, so kumpara nyo dito, ito ay 0, 0.5. Ito ay 0, 0. So anything below 0 dito, okay, will give you this output, and anything above 0 along the x tsaka along the y will give you this output. Okay, so ang isang advantage ito is of course zero-centered na siya. So this is also good for classification. Okay, makikita niyo na continuous din yung ano niya, yung derivative. But like the logistic regression, okay, it also suffers from the vanishing gradient problem. Now, itong activation function na to is rectified linear unit or ReLU. Okay, this is one of tawag dito, the most widely used activation function pagdating sa classification. Kasi it's very simple, okay? Pag below 0, output niya is 0. And pag above 0, ang output niya is kung ano man yung input. So halimbawa dito ang input is 5, ang output mo rin is 5. Okay, so it makes it easier pagdating sa pag-classify ng maraming mga images, okay? Ang advantage ito is computationally efficient. It also accelerates towards a convergent. It converges toward the gradient. Okay? Ang disadvantage nito is nagke-create siya ng dead neurons na hindi mo na pwedeng i-activate pagdating ng pag in-implement mo na yung back propagation. Okay, so kung hindi nyo naintindihan lahat yan, it's fine. Okay. Okay, so ang importante lang dito is kung kailan niyo siya pwedeng, ang importante matutunan at this point is kung kailan niyo siya pwedeng gamitin. Now, ito ay isa ring commonly used na na activation function. This is called a softmax, okay? Ang advantage dito is makes multi-class classification easy, okay? So this is also good for multi-class classification for more than one tawag dito types of classes, okay? More than one class. Okay. So as a rule of thumb, Okay, tawag dito, when doing image classification, okay, so pag image classification lang, okay, you use ReLU as the activation function, okay? If ReLU does not provide optimum results, okay, saka ka lumipat sa ibang types ng tawag dito, ng activation function. Now, ang ReLU gagamitin nyo lang for the hidden layers. So, hindi mo siya gagamitin for the input at saka sa output. Ang sigmoid logistic or at saka tangent, hyperbolic tangent functions ay hindi mo pwedeng gamitin sa hidden layers. Okay? Kasi ang gagawin nila is classify di ba? So, ang output is babato niya kung 0 or 1. Okay? Yun yung ginagawa ng sigmoid tsaka tangent, hyperbolic tangent functions. At saka may problema nga siya sa vanishing gradients, which is not ideal para sa hidden layers. Swish function. Hindi natin wala dito yung swish function. Okay, pero nandito siya. Ito yung swish na function, pero hindi ko actually diniscuss. Pero anyway, is used in neural networks having a depth greater than 40 layers. Pero from my experience, hindi ko pa rin naman ginagamit ang swish function. Typically, ang ginagamit ko is ReLU, softmax, at saka sa input at saka sa output itong sigmoid at saka hyperbolic tangent. Okay, for the output, okay, for the output layer, ang ginagamit is regression, okay, for a linear activation function. Pag binary classification, okay, tulad ng kung flower ba siya o hindi, ang gagamitin nyo is sigmoid or logistic activation function. Pag multi-class classification, mas magandang gamitin ng softmax. Multi-label classification, mas maganda yung sigmoid. Okay, so ito yung mga rule of thumbs. Sa hidden layers, okay, pag there's this type of neural network called convolutional neural network, ReLU yung ginagamit sa hidden layer. Excuse. And then another type which is called recurrent neural networks, ang ginagamit sa hidden layers is hyperbolic tangent or sigmoid activation function. Okay, so ito yung rule of thumb na nasusundan nyo lang pag gagawa kayo ng neural networks. Okay, so let's consider this neural node. So itong image na ito ay i-redraw natin as this image. So ito yung mga inputs natin, and then meron mga weights dito. Okay? And then ito yung activation function, tapos ito yung output in the form of a hypothesis. Okay? Okay, so remember na ang sabi ko yung weights, essentially yung mga theta values. Theta 1, theta 2, theta 3, theta 4, and so on and so forth. Ngayon, kung titignan nyo, yung input is x1, x2, x3. Okay, x1, x2, x3. Pero nagdagdag dito ng x0. If you recall, itong x0 na ito ay yung bias. Okay? And yung x0 is, ang typical values ng x0 ay 1. Okay? So, pero for generality, dadagdag lang natin itong node na to at tatawagin natin siyang x0. Pero alam natin na ang value na is 1. Pero yung theta naught is not necessarily 1 or 0. Kaya natin dinadagdag to kasi meron din siyang corresponding na weight, di ba? So may theta naught tayo dito. And then theta 1, theta 2, theta 3. Okay, tapos lahat ng 'yon, okay, ipapasok natin dito at i-activate yan gamit yung isa sa mga activation functions na pinag-aralan natin before at i-output niya siya in the form of this hypothesis. Okay? Pag logistic function. Sorry. Okay, now this is a more complex neural network kasi dito meron tayong 3 inputs, tapos meron tayong sa hidden layer meron ding 3 nodes. Sa output layer merong anong tawag dito, isang node lang. Okay? So, ang tawag natin dito, okay, is the activation of unit I in layer J. So, activation of unit 1 in layer 2. Kasi nasa layer 2 to, di ba? Activation of unit 2 or node 2 in layer 2. Activation of node 3 in layer 2. Now, we have this matrix of weights controlling function mapping. Again, this is theta. Yung superscript corresponds to the layer number. Okay, so kung ilalagay natin yung theta dito, at saka theta dito, dito, at saka dito. Okay, yan yung, well, lahat ng theta na nandito ay corresponding to layer 1. So, theta super 1 siya. And then dito, lahat ng theta dito ay corresponding to layer 2. So, theta super 2 siya. Okay, na kung titignan nyo, itong x1 is connected, tignan muna natin itong A1 muna, A1. Okay, A sub 1 super 2 sa layer 2. A sub 1 sa layer 2. Itong A sub 1 ay connected sa x1 through this, at saka through this. So, bawat isa sa mga to ay merong weight. Okay. Bawat isa sa mga to, bawat isa sa ng mga yan na nakakonect sa A sub 1 sa layer 2 ay merong weight. So, meron ditong theta, okay, super 1 connected from from x1 to a1. Then itong line na ito ay merong theta, okay, sa layer 1 connected from x2 to a1. And then itong linya na ito ay meron ding theta, okay, sa layer 1 connecting x3 at saka a1. Ganon din sa layer 2. So merong theta sa layer 1 connecting x1 to a2. Merong theta, okay, sa layer 1 connecting x2 to a2, and then meron ding theta sa layer 1 connecting x3 to a2. Ganun din sa a3. Theta connecting x1 to a3, theta connecting x2 to a3, and theta connecting x3 to a3. So, merong 9 na thetas. Merong 9 na weights. Okay, and madali lang naman natin makikita yun kung bakit 9 kasi each node connects to every node dito. So, meron 3 nodes dito at meron 3 nodes dito. So, 9 na theta yon. 9 na anong tawag dito? 9 na weights. Okay. But wait, there's more. Remember, maglalagay tayo ng bias dito. So, meron ka pang x naught dyan. So, ibig sabihin, yung x naught na i-connect mo rin yan dito, doon, at saka dito. So, now, there will be 12. Tama? So, there will be 12 thetas. Okay? That will be 12 weights that describe the connection between layer 1 at saka layer 2. Okay. Pagdating sa layer 2 to layer 3, merong theta, okay, connecting A1 to this node, another theta connecting A2 to this node, and another theta connecting A3 to this node. Tapos, magdadagdag tayo ng bias, okay, which will connect A sub naught sa layer 2 to the output. So, meron tayong 4 by 1, okay, or 4 na weights which connect layer 2 to layer 3. Okay? So, imagine niyo kung gaano karaming theta yung itatry na isolve ng computer. Okay? Before, dun sa logistic regression na example, okay, or dun sa sa cars, 'di ba? Since meron lang 6 na features, ang kino-compute niya lang is 6 na theta. We can write that into a neural network lang din. Okay, ang basically yung cars na yung example ng cars, meron ka lang 6 na input, automatically connected siya dun sa output. Wala ka ng hidden layer. Okay, so 6 na circles, okay, connected to the output. Yun na yung multivariate linear regression. Walang hidden layer. Pero dito, we're processing images kasi. Diba? So we have to add itong mga layers na ito para mas maging, hidden layers na ito para mas maging efficient. Okay, okay. Ito na siya. Ang dinidescribe naman natin dito ngayon ay yung activation function. Okay. So, remember na merong dito, x naught. Okay, x naught. At yung x naught ay yung bias. Okay? So, it will connect to A1, A2, tsaka A3. Okay. Tapos, bawat isa sa mga nodes na to will be activated based on yung input sa kanila. So, for example, itong A1, A sub 1, connected siya sa X0, X1, tsaka X2, tsaka X3. Okay? So, X0, X1, X2, tsaka X3. Yung corresponding na weights niya will be, okay, 0 to 1. Okay? Kaya makikita niyo yung subscript dito is 0 to 1. Ito naman, 1 to 1. Kaya dito yung subscript is 1 to 1. Ito naman is 2 to 1. So dito is 2 to 1. At ito ay 3 to 1, kaya ito ay 3 to 1. At yung superscript is 1 kasi nasa layer 1 lang ito. Yung weight na yan ay yung weights nitong nodes sa layer 1. Lahat ng yan, ipapasok mo sa activation function mo na G. Okay, so kung logistic regression, then G will just be equal to 1 over 1 plus exponential minus Z. Okay, where Z is etong buo na to. Para dito sa second node na to, sa node na A sub 2, okay, so again, meron tayong X0 dyan, it will connect to A2, so from 0 to 2, 0 to 2. And then from 1 to 2, 1 to 2, multiplied by X1. Then from 2 to 2, 2 to 2 multiplied by X2. Then from 3 to 2 multiplied by X3. So ito na yung tawag dito, input dun sa node na ito. And this node will activate the inputs, okay, base dito sa activation function na ito, which in this case is just logistic regression. Itong third node na to will do the same. Mag-accept siya ng input from the bias node. Okay, so from 0 to 3, 0 to 3 multiplied by X0, 1 to 3, di ba? 1 to 3 multiplied by X1, 2 to 3 multiplied by X2, and then 3 to 3, 3 to 3 multiplied by X3. And then i-activate gamit ang logistic regression. Yan na yung nodes natin ngayon. Okay, so ibig sabihin may values to ngayong nodes na ito. Okay. Now, ibabato naman natin tong nodes na ito o yung values nila dito sa output. Okay, so ang gagawin natin, magdadagdag tayo ng bias dito which is A naught, okay, super 2. So, yun yung nakikita nyo rito. And then from 0 to this, okay, sabihin natin 1 ito. So 0 to 1, so 0 to 1. Then 1 to 1, yan yun, 1 to 1. Then 2 to 1, ito yun, 2 to 1. And then 3 to 1, ito yun, 3 to 1. Okay, multiplied by their corresponding nodes. Then we use the activation function on this. Okay, then we get this A13. Okay, so ang tawag dito is A13 kasi nasa third layer na siya, di ba? Superscript is the third, is the number of layer. The layer number. Okay. And yung subscript is the node number. So this will give us the output H sub theta of X. So yan na yung pinaka-output natin. Okay? Okay. So, ganyan nag-work yung tawag dito, yung neural network. Now, makikita niyo yung significance ng pag-create ng function dito, ng sigmoid function kasi i-call mo to every time, i-call mo yun every time. And then ito lang yung i-input mo. Okay, so for each node, mag-iba-iba yung inputs. So you call the sigmoid function or logistic function every time. Okay, and then yun yung magiging yung value niyan, yun yung magiging values ng bawat isa sa mga nodes. Okay. So, ganun yung mangyayari. Okay, now let's consider this example, okay, to a few of these Boolean operators. Okay, ano ba tong Boolean operators? Okay, so yung iba sa inyo, okay, nandito, okay, yung kakaunti sa inyo na nandito is actually taking tawag dito, electronics, physics 173 at ito na yung lesson din sa physics 173. Kung hindi kayo familiar sa Boolean operators na ito, basically ganito lang yan. Itong mga x, xy, xy, yan yung mga input dito. At yung f, yan yung output dito. Okay, so this, you can think of this as an activation function. Itong mga to. Okay, basically, itong symbol ng triangle with the circle is called the NOT function. Itong symbol na ito is called an OR function. Itong symbol na ito is called an AND. This is called an XOR. This is called a NAND. And this is called a NOR function. So, basically, ang ginagawa lang ng NOT function is, kung ano yung input dito, invert lang niya. Yun yung magiging output. So, di ba, ang input is 0, invert niya, gagawin niyang 1. Pag input is 1, invert niya, gagawin niyang 0. So, yan ang NOT function. Ang ginagawa ng OR function is this. Kung isa lang sa mga inputs ay 1, 1 yung magiging output niya. Okay, so, ito, yung inputs ay both 0, so 0 yung output. Ito, yung isa sa mga inputs ay 1, so 1 yung output. Ito, yung isa sa mga inputs ay 1, so 1 din yung output. Ito, both inputs are 1, so 1 din yung output. So, OR. Okay? Yung AND naman is dapat both inputs ay tawag dito, 1. Okay? So, itong first 3, hindi niya satisfy yung condition na yun, kaya yung output is 0. Yung last row, both inputs are 1, so yung output is 1. Yan ang ginagawa ng AND. Ang XOR, okay, is actually the inverse of OR. Sorry. Ang XOR is either one of the inputs ay 1, pero not both can be 1. Okay? So, ito obviously 0 to kasi 0 yung both inputs. Ito, one of the inputs is 1, so 1 yung i-output niya. One of the inputs is 1, so 1 yung i-output niya. Ito, both inputs are 1, so 0 yung i-output niya. Okay? Kasi ang XOR, ginagawa ng XOR is only one of the inputs ay dapat 1. Ang ginagawa ng NAND is the inverse of AND. Okay? Alam naman natin na inverse siya kasi merong maliit na dot doon katulad dito. Okay? So if you see this, so well, this is an AND. Okay, medyo confusing ano. Okay, okay. Kasi ito OR pero nandoon siya. Pero in any case, this is an wait. NAND, not AND. Mali yata ito. Okay, mali itong mali nakasulat dito. NAND is the inverse. So, dapat ito ay 1. Okay, dapat ito ay 1, dapat ito ay 1, at dapat ito ay 0. Okay. So, yan. Okay, so inverse lang siya basically ng AND. So, it's not AND. Yan lang yun. And then yung NOR is inverse ng OR. So, it's not OR. So 1, 0 ito, 1 doon, and then ito ay 1. So, ito lahat magiging 0. Okay, now, we're going to use, dinescribe ko to kasi gagamitin natin to as examples para makita natin kung paano nag-work yung neural networks. Okay, so ito yung logic AND. Okay, so let's begin with the logic AND function. Okay, wait a second. Okay. Okay, so meron tayo nitong dalawang inputs, x1 tsaka x2. Okay, remember na yung AND is, di ba? Dapat both inputs ay 1. Okay? Otherwise, 0 lahat ng output niya. Okay? So, dapat both inputs ay 1 para yung output dito is 1. Okay? So, yun yung objective dito. Now, ang ginagawa nyo sa machine learning is ipapa-determine nyo sa computer kung ano yung theta values. Theta dito, tsaka theta dito. Yung mga weights. Yan ang i-compute ng computer. So, after niya mag-compute, isasabihin niya sa iyo kung ano yung mga theta values, yung mga weights. Okay. So ano ba ang magandang value ng weights dito? Of course, pag finid natin yan sa computer, mag-compute siya iteratively hanggang sa maging minimum yung error. Okay, pero okay, just for the purposes of this exercise, okay, let's say na ang value nito is itong weight na ito, okay, itong arrow na ito, no, itong line na ito is -30. At ito ay 20, tapos ito ay 20. Okay, so theta sub 0, 1, okay, is equal to 30. Ito naman ay 20, ito ay 20. Okay? Pwede ba ako mag-draw dito? Yan, pwede yata. So, -30. Ito ay 20. Ito ay 20. Okay? Okay. So, anong mangyayari dito ngayon? Okay, so, ang gagawin natin is isusulat natin itong mga to. Okay? In terms of a function muna. Okay, so, ito is theta naught. Okay, yan yung equal sa -30. Eraser. And this is theta 1. Ito ay equals to 20. At ito ay theta 2. Ito ay equal din sa 20. Okay? So, idea is, remember this is x naught. Okay? Diba? X naught yan is equal to 1. So, theta naught times x naught. Ito yan. Theta naught times 1. Okay? Times 1. May x naught ka dyan. Okay, plus theta 1 times x1 ito. Theta 1 times x1 plus theta 2 times x2. Theta 2 times x2. Okay, so yan na yung i-input natin dito sa G. Okay, so yan yung input natin sa G. Dapat ito ay G. Ganyan. Okay, so. Okay. Sige, ayusin na natin habang nandito. At ito ay parenthesis. Oops. G. G. Ganyan siya. Okay, so, yan yung G. Okay, so tignan natin ngayon. Ito yung ating truth table. By the way, ang tawag pala dito sa mga to ay truth table. So, what if both inputs x1 and x2 are 0? So, ibig sabihin, ito ay 0, ito ay 0. Ano itong magiging theta dito ngayon? Okay, ano yung magiging theta sub t? Ang magiging theta super t, theta transpose of x, theta transpose times x is, since sinabi natin na -30 ito ay 2020, ito ay -30. Okay? Tapos ito ay 20 pero 0 ito. Ito naman ay 20 pero 0 din ito. Okay, so ibig sabihin, itong nasa loob ng parenthesis is -30. Okay, now, ipapasok natin yan dun sa ating activation function, G. Ito yung G natin. Okay? So yung Z natin dito is -30. Ito yung Z values. Asan ang -30? Ang -30 nandoon. Nandito yung -30 banda. At anong value ng G? Sa negative, pag Z is -30? 0. Okay? So, 0 yung value ng H of theta of X. Okay? Pag ang X1 tsaka X2 ay 0. Okay? Now, what is paano naman kung ang x1 is 0 at ang x2 is 1? So ibig sabihin, ito ay -30, ito ay 20 times 0, ito ay 20 times 0. So meron tayong negative 30, meron tayong plus 20 dito. So ang value nitong nasa loob nito is negative 10. Ipasok mo yung negative 10 dito, okay, sa g of z. So yung z natin is negative 10. So titingnan natin itong graph. Nasaan ba yung negative 10? Ang negative 10 is somewhere here. At anong value ng g? Ang value ng g is 0. Tama? So, again, this is, ang hypothesis natin ngayon dito is 0. Okay. In the same way, pag ang input is 1, x1 is 1, at x2 is 0, ito ay negative 30, ito ay 20 times 1, ito ay 20 times 0. So, itong buo na to is negative 10 din. Okay, kasi negative 30 plus 20. So, so z is negative 10. So, nasa ng negative 10 dyan? Nandito banda ulit. So, ibig sabihin ang value niya is 0. Value ng g is 0. Finally, pag 1, ang x1 is 1 and x2 is 1, then ito negative 30, ito is 20 times 1, ito is 20 times 1. So, this will be 10. So, z is equal to 10. At yung z is equal to 10 ay nandito banda. At ang value ng g doon is 1. Okay? So, ang ginawa natin dito is basically, nag-define tayo ng theta, values ng theta, in such a way na may implement niya tong logic and na truth table. At yun yung gagawin din ng computer. Ang gagawin ng computer is i-determine niya tong values na ito, negative 30, 20, 20. Okay, so gagawin niya yan, gagawa siya ng many iterations hanggang sa makuha niya tong negative 30, 20, 20. Okay, para makuha niya tong values na yan. Okay? Okay, now implement naman natin yung logic or dito. So, ang gagawin natin dito is etong theta naught will be, we'll set it equal to negative 10. Wait, teka. Negative, 10 pala, 10. Okay. So, 10, so positive 10. Tapos itong theta 1 is negative 20. Ulitin lang natin. Theta 1 is negative 20. Theta 2 is negative 20. Okay. So, gawin natin ulit ito. G. Okay. So, ito ulit. So, ito naman ngayon is positive 10. This is negative 20. This is negative 20. Okay? Tama ba? Negative 10, 20, 20. Baliktad. Negative 10, 20, 20. So, this is negative 10. Okay. This is negative 10, 20, 20. So, ito ay negative 10. Okay. Okay, so negative 10, 20, 20. Okay. So pag ang x1 ay 0 at ang x2 ay 0, so ito ay 0, ito ay 0, ang matitira ay negative 10. At so z is equal to negative 10, nandito siya. So g is equal to, ang tawag dito, 0. Okay. So pag x1 is 0, x2 is 1, okay, x1 is 0, x2 is 1. So ito ay negative 10. Ito ay negative 10. Ito ay 20. So ibig sabihin, itong buo na to will be 10. Okay, so ibig sabihin, z is equal to 10. Ang z is equal to 10 ay nandito. So ibig sabihin, ang h of theta is 1. The same way, x1 is 1, x2 is 0, ito ay 20, ito ay negative 10. So itong buo na to is positive 10 at ang z equals positive 10 ay nandito. So this will be, the output will also be equal to 1. Tapos ito, okay, will give us, ito ay 1, ito ay 1, ito ay 1. So this is 20, this is 20. So 40 na yan, and then may minus 10 ka doon. So 30 ito lahat. So z is equal to 30 at ang 30 ay somewhere here. At obviously yung g dyan is 1. Okay, so ngayon na-implement na natin. Okay, by determining itong theta values na ito, na-implement na natin yung logic OR. Okay, what about itong logic NOT? Okay, dito sa logic NOT, ang gagamitin natin dito ay ay, logic NOT is ano na nga ang value dito? Ay, hindi. Logic OR sa logic NOT negative 10 at saka positive 10. Okay, negative 10, positive 20. Okay, so this will be theta naught equals negative 10 and this theta 1 is positive 20. Okay, so basically pag this is negative 10, ito ay positive 20. So pag ang x1 is 0, then negative 10 yung z. So ang g mo is 0. G mo is mali. G mo is baliktad. So this is yan dapat. Positive 10, ito ay negative 20. Okay. So this is positive 10, ito ay negative 20. Okay, so ang output mo dito is ang z mo is 10, so ang output mo is 1. Ngayon, kung x1 is 1, so ibig sabihin negative 20 to, tapos ito ay 10, so z mo is negative 10, so ang output mo ay 0. Okay, so ito yung values na magbibigay sa iyo ng ganitong ng tamang proof table. So logic not x1 tsaka not x2. Okay, ito yung 10, negative 20, negative 20. So ito sila. 10, negative 20, negative 20. So theta not 10, theta 1 is negative 20, theta 2 is negative 20. Okay? Ang not x1, ibig sabihin babaliktarin mo. Okay? At ang not x2, babaliktarin mo rin yung input. So ganito. So x g. So okay, so this is 10, this is negative 20, this is negative 20. So pag ang input mo is 0, 0, okay? Since not x1 to, gagawin mo siyang 1, i-invert mo siya, di ba? Not x1 eh. So invert mo to, gagawin mo 1 tsaka 1. So ito ay 1 ngayon at tsaka ito ay 1. Since ito ay negative 20, ito ay negative 20, so may negative 40 na tayo dyan. Tapos may 10 tayo dito. So ito yung z is negative 30. At yung negative 30 is somewhere here. So yung g corresponding to that is 1. 0. Okay. Tapos, ito ay 0, 1. Okay. Babalik na rin natin yan. So ito magiging 1. Ito magiging 0. So meron tayong negative 30 dito. Negative 20. And then plus 10. So itong buong z na to, yung z dito is negative 10. So somewhere here. So, 1. Output niya is 1. 0. Sorry. 0. Okay, tapos 1, 0. So gagawin natin itong 0 kasi not x1. Ito gagawin natin itong 1. So, -20, +10. So, itong buo na to ay -10. Okay. So, -10 is somewhere here. So, ang G is 0. Tapos, ito ay 1, 1. So, ibig sabihin ito ay 0, 0. Okay, kasi not. Okay. Tapos, ang matitira na lang is +10. So, +10 ay nandito. So, yung G will be 1. Okay. So, ito ba yung tamang truth table? Okay. Ito yung ang not x1 tsaka not x2, tapos i-end mo sila. Okay. Ibig sabihin, 'di ba, ang end is pagpareho, pagpareho yung end. Ito. Pagpareho yung end, 1 siya. Pero pag not x and not y, okay, dapat, tawag dito, mag-invert dito. Okay. So, yun ba yung nangyari? Oo. So, not x. So, halimbawa, not x. So, ito 1, 1. Dapat ito ay 1. Ano? Dapat, dapat ito ay 0. Baliktad. Baliktad. So, may mali dito sa theta not na ito. 10, -20, -20. 10, -20. 10, -20, -20. So, dapat dito yung 1, dito yung 0, 0, 0. Okay. Teka, i-figure out ko yan later, pero ignore mo, tawag dito, mag-move na lang tayo just for the purposes ng ano, ng, kasi yung time. Second. -10, 20, 20. 10, negative. Okay. Anyway. So, 10, -20, -20. Okay. Anyway. Okay, so mag-proceed na lang muna tayo dito. Okay. Okay, now, anong gagawin natin dito? Ang gagawin natin dito is we'll try to develop an XNOR logic truth table. Okay? Pero to do this, gagamit tayo ng neural networks. Okay? Okay, so ang gagawin natin is we're first going to create a tawag dito, one node here that connects ito, at saka ito. Okay, tatawagin natin siyang A1 and then syempre layer 1. Layer 2, sorry. Layer 2. Okay. So ito yan. Okay. And then gagawa ulit tayo ng pangalawang node dito. Okay, pangalawang node dito. Tatawagin natin siyang A2 sa layer 2. That connects this, and this. Okay? Okay. Tapos, na-determine na natin ito yung mga weights na nasa, na na-determine natin before. So, lalagay natin yung weight na to. -30, 20, at saka 20 dito. And then, for this, ito ay 10, -20, at saka -20. Okay, remember, itong mga weights na to, yan yung dinedetermine ng computer. Okay, yan yung hinahanap nyo actually. Yeah, well, ang idea dito is initially magbibigay kayong values nito, di ba? Tapos yung computer na lang ang mag-optimize niya. So tignan natin kung anong value ng A1. Okay, anong value ng A1? So ito ay magbibigay ng this corresponds to an end, di ba? So nakuha na natin itong value niyan. So dahil end siya, ito ay 0, ito ay 0, ito ay 0, at yan ay 1. Okay, tapos ito ay eh, not x1 at saka and not x2. Ang sabi natin, dapat ang lalabas dito is 1, 0, 0, 0. Okay. Okay, so ito na yung lumabas dito yan na yung mga values nitong functions na ito. Okay? Okay, now we're also going to add a bias here. Okay, ayan yung bias na yan is A not sa layer 2. Tapos, i-connect na natin siya dun sa output. Okay? Which is nasa third layer. At ang output is A1 third layer. Okay? Tapos nakakonekta yan dito sa tatlo. Tapos yung weight na gagamitin natin ay itong mga to. So, negative 10, 20, 20. Okay? And since alam natin na OR yan, either isa lang sa kanila yung 1, magbibigay siya ng 1. So, isa sa kanila dito ay 1, so ito ay 1. Ito ay both 0, so ito ay 0. Ito ay both 0, ito ay 0. Ito ay isa sa kanila ay 1, so ito ay 1. Okay, so ito na yung XNOR natin na logic function. And we did that by using neural networks. Okay, now itong exercise na to sort of tells you kung anong nangyayari dun sa computer. So yung computer first solves for these nodes. Okay. Okay, so ganito. Magbibigay kayo ng initial values of weight. So iba yung values nito initially. Based on dun sa binigay niyong values, isa-solve niyo itong values ng nodes na ito. Tapos, okay, ito initial values dito na kayo magbibigay, and then magso-solve siya nitong value dito. So i-check niya ngayon yan sa ano, sa true value. Okay, so i-check niya sa true value. Okay, check. So kung ano man yung true value na yan. Okay, so true value. Makaka-compute siya ngayon ng error. Okay, so ang gagawin niya is pag na-compute niya yung error, okay, merong process na tinatawag na back propagation. Okay, and kung pinag-aralan niyo yung matrix algebra, or kung pinag-aralan niyo nito sa 122, yung term na sa physics 122, yung term na back propagation sa 122 is exactly the same as yung back propagation dito. So ang ginagawa dito is, based on this error, i-recompute nung computer itong mga theta values na yan. Okay, so una niya i-compute ito, and then susunod niya i-compute ito. Okay, now based on these new theta values sa first iteration, magpo-forward propagation ulit siya. So compute, 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 and then compute, compute, compute. Tapos may bago kayong values for these nodes. Bias ulit, which is just equal to 1, di ba? And then based on yung na-compute na bagong values ng theta, magkakaroon ulit kayo ng bagong value ng A sub 1 of super 3. Compare it with the true value, and then solve for the error. So, gagawin niya ng computer paulit-ulit forward and back propagation, paulit-ulit, hanggang sa makuha niya tong mga optimum values ng theta. Okay, so ganun yung nangyayari dito. And dito nyo gagamitin ngayon yung gradient descent. Okay? Dito sa pag-minimize nitong error na ito. Okay? Okay. So, any questions? Okay. So, walang tanong. Teka. Okay, so kung walang tanong, let's take a look at this uh, code muna. Okay. Now, if you have an image, okay, kung meron kang image file, okay, kahit na JPEG yan or PNG or TIFF, nababasa yan ng MATLAB, nababasa din yan ng Python. Okay, ito yung gagamitin nyo na ano, na function, IMShow. So first, kailangan nyo munang i-read yung image. Pagkatapos yung i-read yan, isi-save nyo siya as a file. In this case, yung file is IM. Okay, yung file na IM ay isang array. Okay, which is yung kaninang tinitignan natin na RGB. Tawag dito, RGB uh, array. Kung titignan niyo yung ayan, yung IM na function, IM na variable, meron siyang 1680 by 2240, okay, na pixels by 3 kasi meron siyang 3 layers. Okay? So, tignan natin yung mga layers na yan. So, kung ipapakita lang natin yung buong syempre, isi-superimpose niya yung tatlong layers. At ito yung itsura ng superimpose na layers. Ito yung layer 1. This is the red. Ito yung layer 2. This is the green. At ito yung layer 3. This is the blue. Okay? So, mapapakita niyo yan using simply these commands. Okay? So, first two layers ay yung pixels at yung first two columns ay yung pixels at yung last column ay yung layer number. Okay, so layer 1, layer 2, layer 3. Okay, and then, of course, pwede nyo ipakita yung grayscale image by simply using this command RGB to gray nung IM. Okay, so, saan na ba yun? Ito yung grayscale image. Ito ba yun? Sorry. Ito yung grayscale image. Ito. Yan yung grayscale image. Okay, and anong tawag dito? Of course, pwede nyo rin ipakita yung intensity per pixel. So, in the form of a bar plot. So, ito yung image na. So, pag, okay. Okay, the same way sa Mango, ganun din yung ano. So, i-read nyo lang yung Mango na file. Okay, dito. Okay, pakita nyo yung layer 1, layer 2, at saka layer 3. The red, green, and blue layers. Okay, so ito yung commands para ipakita lang yung images. Okay, now in MATLAB, meron ding available na dataset na ganito. Okay, so pinakita kina before kung saan yung makukuha yung mga dataset na yan. So this is one of the many datasets na available sa MATLAB. So this is an iris dataset kasi this classifies these three types of flowers. Okay, so 1, 2, at saka 3. Iris setosa, Iris versicolor, tsaka Iris virginica. Yung dataset na yan, okay, nasa nakamat file, okay, so meron siyang 4 by 50 na datasets. Okay? 4 by 50 na array. Bakit tatlong beses itong na-print? Okay, at ito yung tinatawag natin na targets, which I will explain sa next meeting. Okay. Okay, so ito yung pag-aaralan natin yan sa next na meeting. Yung mismong code for the neural networks. Okay, oops, nangyari. Now, bago tayo mag-dismiss, let me just show you another slide. Okay, now itong slide na ito, ay optimization algorithms. O itong ano na to is about optimization algorithms. So, meron na kayong isang alam na optimization algorithm at yun ay gradient descent. But there are many other types of optimization algorithms. Okay? Meron stochastic gradient descent, mini-batch stochastic gradient descent, stochastic gradient descent with momentum, SGDM, Nester of accelerated gradient, NAG, adaptive gradient, ADA delta, RMS prop, tsaka Adam. Okay? Ito yung mga differences nila. Okay, so, halimbawa yung SGD, makikita nyo kung gaano ka bagal, actually, kulay pula. Kung gaano siya kabagal mag-approach sa optimum value. Ang mapapansin yung mga mabibilis mag-approach ay yung itong actually yung pink at saka yung green, NAG, tsaka yung SGD with momentum, offshoot and then saka siya dahan-dahan pupunta doon. Pero yung black, for example, RMS prop, slowly siya pumupunta sa sa optimum value pero mas mabilis pa rin kumpara sa stochastic gradient descent. So, this image describes yung kung gaano kabilis mag-approach sa minimum value, sa optimum value at tawag dito at kung paano niya kung ano yung approach niya, di ba? Dito rin makikita niyo rin na yung blue, okay, which is ADA gradient, okay? Mabilis siyang after just a few iterations, makukuha niya na yung accuracy na 80-90%. Okay, yung red talagang mabagal, stochastic gradient descent, mabagal talaga siya. Okay. Tapos then yung black at saka yung ibang colors ay halos magkakasabay na lang. Okay. So, ito yung iba't ibang optimization algorithms na available sa MATLAB at saka sa Python. Okay, so this slide describes yung iba't ibang types ng gradient descent. Okay, pero hindi na natin i-discuss ito. Okay, ito na lang yung i-discuss natin. So when to choose an algorithm. Okay, it is observed that the SGD algorithm red is stuck at the saddle point. Okay, so kung meron kayong ganitong curve, okay, na merong saddle point, hindi maganda yung SGD na algorithm. Okay. It's typically used for shallow networks. Pag sinabing shallow networks, ibig sabihin isang hidden layer. Pwedeng dalawa, okay, pero hindi na siya kasing efficient pag isa lang. So, isa, dalawa, okay pang SGD. Next, all the other algorithms except SGD converges one after the other. ADA delta being the fastest, followed by the momentum algorithms. Okay. ADA grad and ADA delta can be used for sparse data. Okay, so since images naman yung inaano nyo, hindi importante to for now. Momentum and NAG work well for most cases pero mabagal. Okay, animation for Adam is not available, but from the plot above, from this plot, it is observed that the fastest algorithm to converge to minima. So Adam is one of the most commonly used optimization algorithm. Okay, Adam is considered the best algorithm amongst all the algorithms discussed above. Okay? Of course, kung single hidden layer ka lang, wag mo nang gamitin yung Adam kasi, di ba, parang overkill. Okay, so stick ka na lang sa SGD. Okay, so, yan. Okay, so ito lang yung actually gusto kong ipakita dito sa slide na ito. I-upload ko pa rin tong mga slides na to just in case na interesado kayong mapag-aralan kung ano yung iba't ibang types nung gradient descent. Maybe sa next meeting itong mini batch at saka mini batch na gradient descent i-discuss ko kasi importante rin tong yung ibig sabihin ng mini batch, not necessarily yung gradient descent but yung ibig sabihin nung mini batch. Okay. Okay. So okay. I think that's it for this meeting. Okay, so sa Thursday, yung last meeting natin for the semester, okay, di-discuss natin yung tawag dito, classification by ng images. So, let me just share this then. So, una nating i-discuss is classification nitong iris na flowers. Okay? Ano yung algorithm na gagamitin natin dito? Okay? At pangalawa nating i-discuss na example is itong sikat na digits. Okay? Yung numbers. How to classify 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 yung na digits. So for example, ito digit 9, ito digit 4. Tignan natin kung paano to i-classify. Okay, based on tawag dito. Based on the images na feed natin sa computer. Okay, so ito yung mga tinatawag na MNIST images. So NIST is the National Institute for Standards and nakalimutan ko yung T, technologies. And then yung M is also something. Okay, so NIST is yung standards, yung institution sa US na nagde-determine ng mga standards. So sila yung gumawa nung digits na ito. Actually, ang ginawa nila is kumuha sila ng a certain number of students, pinagsulat nila yung students ng iba't ibang numbers. 0 hanggang 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Tapos dinigitize nila yung mga numbers na to. So ito ay sulat actually ng mga bata. Itong mga numbers na ito. Okay. So yun yung gagawin natin na next meeting. Now your machine problem will be something similar dito. Okay, sa ano na to, sa work na ito. Okay, so you're also going to classify images. Okay, so ako magpo-provide ng images and ika-classify niyo yun. At titignan niyo kung gaano kataas yung success rate ninyo. Which I will describe next meeting. Okay, so any questions? Any questions? Okay, so kung wala nang tanong, then I'll see you on in our last meeting on Thursday.